Honeycomb's new Bravo Throttle Quadrant comes with both commercial and general aviation throttle levers, as you can see in this picture. In this video, I'll quickly show you how to configure Microsoft Flight Simulator 2020 to utilize the various throttle configurations for the different types of aircraft in the game. The first thing that you need to do is go to the Options Controls menu. At the time of recording this video, there's a bug in Microsoft Flight Simulator with the default throttle quadrant setup. Essentially, throttle number 2 does not work. I posted another video how to fix this. I'll put that in a link above. After you fix the throttle bug, you'll wind up with a new profile. I named mine Complex Twin since the default profile is for a twin-engine GA aircraft. And here I demonstrate throttle number 2 working properly. There's one step that you're going to want to do before setting up the various throttle profiles, and that is assigning the Bravo switches to what you want them to control. We're using one master profile to create all of the others, so you'll be copying whatever switch configuration you have preset in your starting profile. By default, the switch keybinds are exactly the same as the Alpha Flight's yoke, beacon, landing, taxi, nav, and strobe lights. Since I already used the Alpha control yoke, it was unnecessary to keep the duplicate switch bindings. I've personally set my switches to anti-ice, windshield de-ice, pitot heat, cabin lights, flashlight, yaw damper, and parking brake. You're going to want to make yours whatever you want. Now that all my switches are set, I'm going to configure the throttle quadrant from a twin-engine GA aircraft to a complex single. I'm going to start by removing the number 2 mixture, number 2 prop, and throttle. Next, I'll move everything over to the left side so they're right next to each other. The final step is to take all the levers to the right and move them down past the detents so they're out of the way. If you want to use the rubber covers, that's optional. I just put it in here for completion's sake. So the next thing you're going to do is we're going to go to the preset manager and copy the existing profile. I'm going to rename this profile to Complex Single, since that's what we're configuring. The first thing we need to do is get rid of the 3 levers to the right. So throttle number 2 decrease button, all gets deleted. Next, the propeller number 2 axis, clear that. And then also we're going to clear the toggle the feather switch number 2. And lastly, we go up to the mixture. We're going to get rid of mixture number 2 axis. We'll clear that out, as well as the decrease mixture number 2. We've essentially eliminated the right engine of a twin-engine aircraft. As you can see here, throttle number 1 is still set, so there's absolutely nothing that we need to do here. But we do need to configure the other 2 levers, starting with the prop. We set this, we just move the prop lever down, validate it, and then the feather switch by moving it past the detent and validate. For the mixture, we go up to mixture number 1 axis and we clear that out and rebind it to the new mixture lever, validate. And lastly, the decrease mixture 1 button by going through the detent, and we validate that. The final thing I'll do is I'll push all the levers forward to make sure that they're functioning properly, and then pull them down through the detents to make sure the buttons are working as well, and we've set up the complex single-engine aircraft. Now to create a basic single-engine aircraft, it's quite simple. We just remove the prop lever and put the mixture lever in its place. Before, I'll move the empty lever down and conceal it with the rubber cover. The last step is to apply and save for this profile before going to the preset manager and creating a duplicate of this so that we can create our basic single profile. Basic single-engine trainer aircraft like a Cessna 152 only has 1 throttle and 1 mixture lever. Like before, it's a matter of deleting the thing we took away, so we're going to delete the prop lever as well as the throttle feather switch from going through the detent. Nothing needs to be done to the throttle. It's still bound as throttle number 1. but we do need to rebind the mixture. So we'll go to mixture 1 and move the mixture lever down and validate it. Likewise, we're going to go to the decrease mixture 1 and pull the lever through the detent to bind that. Now the throttle quadrant's properly configured for basic single engine controls. I'm going to apply and save this profile before moving on. Once again, we're going to start with the basic single and go to the preset manager and duplicate that. And we're going to change this to a 4-engine jet profile. With the 4-engine jet profile, we're going to reassign every lever in the throttle quadrant. That's why it's good to start with the basic single, because essentially you only need to delete one mixture control. I've now reconfigured the throttle quadrant to have the jet engine controls installed. The first thing I'm going to do is reassign throttle number 1 to the new throttle number 1 in the jet engine configuration. I'm also going to clear out the throttle number 1 decrease binding because that's going to be reassigned to the reverser levers in the jet throttles. At this point, I'm going to stop assigning throttles and go all the way to the first lever, which is the speed brakes. In Microsoft Flight Simulator, search for spoiler and you'll find the spoiler's axis. And we're going to go ahead and bind the spoiler's axis for lever 1. You do not need to click reverse axis. It works properly in this configuration. Now let's jump over to the other side of the throttle quadrant and set the flap lever by searching for flaps and choosing flaps axis -100 to 100% and bind that lever. And once again here, you need to click reverse axis. It works properly in this configuration. Go back up to the search by name and type in the word throttle. This will bring up all the different throttles where we can do the bindings for. We've already set throttle number 1 axis, and you can see it works properly here. Find throttle number 2 axis, and let's bind that to throttle number 2. Validate. Go down and find throttle number 3 axis. And we'll bind that to throttle number 3 and validate. Oh, you know what? Don't forget to go back and click reverse axis for throttle number 2 and number 3. They have to be selected for this to work properly. And last but not least, we'll take throttle number 4 axis and we'll bind that to throttle 4. And like we just did for 2 and 3, we will click the reverse axis box. So now the throttles are all configured properly. Now the next binding is optional. I like to set moving through the detent on the throttles as a throttle cut, which will cut off the throttles if you move them through the detent. And I'll show you why that is useful a little bit later here. So I'm going to quickly bind all 4 throttles by moving through the throttle detents and assigning them to the throttle cuts. Now that the 4 throttles and their respective cutoffs are set, the last thing to do is to assign the reversers. The commercial jet throttles have reverser levers mounted directly on the throttle levers. You bind these to the throttle decrease fields in Microsoft Flight Simulator. Bring up the throttle 1 decrease field and flip the reverser lever backwards on the throttle to bind it. I'm going to quickly apply and save this and go into the Boeing 747 cockpit so we can see the results of our bindings. The speed brake works fine. If I push it forward, you can see it move forward in the simulator. Also, the flaps on the right side. I've only bound throttle number 1 at this point, but you can see it works fine. If I pull back on the reverser lever, you see that works properly in the simulator as well. Remember I said there was an advantage to the optional engine cutoff binding? It comes in handy here using the reversers. If I engage the reverser and then I flip the reverser lever forward again, it doesn't come out of reverse. I can make it come out of reverse simply by pulling it down into the cutoff detent. Now all you have left to do is add the reverser to the throttle 2, 3, and 4 decrease by bringing each one up and flipping the reverser switch backwards to bind it for all 4 throttles. When you're done, apply and save. I'll quickly jump back to the 747 and make sure all the reverser levers do indeed engage, and certainly they do. And lastly, a quick check of all the throttles, and all the throttles move. Looks good. Now that I've confirmed everything is working, I'm going to make one more profile. Much like we use the most complex twin-engine airplane as the starting point for our single-engine aircraft, we use the 4-engine jet as the starting point for our final 2-engine jet profile. It's a simple matter of deleting 2 engines and rebinding throttle number 1 to do this. As you can see, I duplicated the 4-engine jet profile and named it 2-engine jet. So we're going to go here to the throttles, and here we're going to eliminate throttle number 3, throttle cut number 3, throttle 3 decrease, so that gets rid of the throttle, the cutoff, and the reverser. And we're going to do that all for throttle 4 as well. I've gone ahead and reconfigured the throttle quadrant to have 2 throttle levers, and I just need to set this up in Microsoft Flight Simulator. What's involved is reassigning the throttle number 1 axis, throttle number 1 cut, and throttle number 1 decrease for the reversers to the new throttle number 1. Throttle number 2 axis is rebound to the throttle 2. Throttle 2 cut by pushing the throttle through the detent. And finally, throttle 2 decrease by pulling back on the reverser lever. Last thing to do is apply and save our final profile, this 2-engine jet profile. I'll go back to the 747. You can see the reversers and the throttle levers work as intended. If you've made it through to the end of the video with me, you've now configured a twin-engine GA aircraft, a complex single, a basic single, a 4-engine jet, and now a 2-engine jet. Enjoy flying all your different airplanes and all the different throttle configurations.